Good morning, this is Miss Webb. I'm going to go over 3 really important properties with you. And then we'll do an assignment and I'll try to break them out for you, but a lot of times they're combined together. And what's so nice about the root laws and properties of exponents, the order doesn't really matter. We don't have to use PEMDAS in the sense that, am I going to use the upstairs downstairs rule first, or am I going to do these different properties I'm going to go over with you. Which one do I have to do first? You don't have, there's no specific order, and I'll show you that. And that's what makes the law of exponents. It gives you a little bit of creativity. Okay, so let me get over there. Okay, and let me make this a pen. Okay, the very first property is multiplying powers with the same base. For every non-zero number a and integers m and n. So here is A, that is your base. The M and the N are your powers. So if you had A and A was exactly the same, your bases were the same, then you're allowed to add the powers. Let me show you an example. If you have 3 to the 5th and 3 squared, 3 is the base. It's the same over here, it's a 3. So what I can do is say 5 plus 2 is 7. Same base, but you add the powers. Okay. Now when I say when in doubt expand it out, look at this. You have 5 3's multiplied together. You have 2 3's multiplied. What does that equal? Aren't there 7 3's total? It would be 3 to the 7th. Okay, let's try this one down here. The x is your base, and it's exactly the same. And you have 2 and 4. So I add them together to get 6. Notice this. On this one right here, I could do 3 to the 5th times 3 to the negative 2. I could say 5 plus negative 2 is 3 cubed. But what if I wanted to do that upstairs downstairs rule first? Well, you could do that. You could say 3 to the 5th times 1 over 3 squared. Okay? And you would get 3 to the 5th over 3 squared. We have not done this property yet, but when you divide, you're going to subtract, and I still get 3 cubed. Okay, but I don't want you to deal with that right now because we haven't gone over all the laws and properties. I, in this particular case, would have added 5 plus negative 2, gotten positive 3. Now, I don't want to see any 3 cubed. You should put that in your calculator and get 27. Okay? 3 times 3 times 3. I don't want to see any 9s. It is not 3 times 3. This is, if you put it in your calculator, 3 times 3 times 3. It's equal to 27. Okay, let's look down here. Again, negative 2 plus 4 gives me a positive 2. I can only do this when the bases are the same. Okay, let's look at another example. Okay, let's give these a try. On this one right here, I want to make sure, let me get my pen going over here. Okay, you could think of the 2 as having an exponent of 1, 2 to the 1. And you have n to the 5th power. That 5 does not go on the 2. Okay, the 5 is only on the n. Then I'm going to multiply 3, which you could think of that as having the power of 1, times n to the power of negative 2. So when I go to multiply those, I'm going to multiply the 2 and the 3 together, and I get a 6. Now when I multiply n to the 5th times n to the negative 2, the bases are the same. The base is in, the base is in. So I get n, and I'm going to add 5 and negative 2, and I get 6n cubed. And I'm done. Let's come down here. I could think of 5 as having a power of 1. Okay, look at this x. I could think of it as having a power of 1 too. The 2 does not have a power. It could be 2 to the 1, y to the 4th. You could think of this as 3 to the 1, x to the 8th. Okay, I'm just going to come over here and I'm going to multiply 5 times 2 times 3. That would be 10 times 3 is 30. Those are all my constants. Now I'm going to come back and look at my variables. I have an x to the 1. No x's here. Here's my x to the 8th. I am going to add the 1 and the 8 and get x to the 9th. Now I'm going to go back and look, I have that y to the 4th. It's right there. And you cannot combine those. They're not like terms. Remember, to have like terms has to be the same base and the exact same power. But those are different. Okay. Now trying this again, I keep getting interrupted. Here we go. This is raising a power to a power. For every non-zero number, a, here's your a there, and integers, m and n. If you have a to the m, and notice they're in parentheses here, then you're raising this whole thing to the power of n. And what you do when you do a power to a power, you multiply the powers. Let me show you some examples. If you have 5 to the 4th, notice that's in parentheses, you're going to raise it to the power of 2. So you're going to multiply the powers and you get 5/8. And you should put that in your calculator and get a constant. Okay, if I have x2 to the 10th, I'm going to raise a power to the power. It's 2 times 10, x to the 20th. Look here, this one, negative 4 times 7. I get a negative 28. Can you have a negative exponent? No. Use that upstairs, downstairs rule. It's an x to the positive 28. That's how you can combine the properties. Okay? Another way you could have done that was you could have said, okay, well, I got x to the negative 4th in the parentheses. I'm going to fix it first. X to the 4th to the 7th. And then that would have been 1 over x to the 28th. Could have done that. Doesn't matter the order. Okay, let's try another one. Okay, this is the third one. It's called raising a product to a power. It's when you have more than, it says product because these are multiplied together. So for every non-zero number a and b, when you have the product of these two numbers, and you're going to raise it to the power of n, the n has to go on the a and the b. That would be the same thing as a to the power of n and b to the power of n. And the important thing is, you see these parentheses? That's what makes the difference. If there was no parentheses, that n would only be on the b, it would not be on the a. Okay? But when you have the parentheses, then it's a to the n, b to the n. Let's do some examples. If you have 2 to the x, it's in parentheses, cubed, that means the 3 goes on the 2 and on the x. 2 cubed is 2 times 2 times 2. It's an 8. And x cubed. I don't want to see 6's here. This is the same thing as 2 times 2 times 2. It's 8. It's not 2 times 3. Okay, look at this one here. Let's see what order we're going to do this in. This is x to the negative 2 to the second power. I'm going to do my power to a power rule, and I'm going to get to the negative 4th. Then I'm going to take this 4 here, and I'm going to put it on the 3, the x, and the y. When I do a power to a power, I multiply. Okay. Notice I didn't take care of that negative exponent yet. But look, when I go and I multiply, I'm going to use that first property. I'm going to add. Well, here's my x, same base. Anybody else the same base? Yep. What's negative 4 plus 4? I get x to the 0 power. 3 to the 4th, y to the 8th. And what is anything to the 0 power? 1. So that's 1 times 3 to the 4th, y to the 8th. Oops. Which is equal to 3 to the 4th. I don't know why my pen's messing up. Y to the 8th. Okay, and I'm going to give you a chance to practice all of these. Okay, so good luck.